Okay, so another typical 2 marker, and maybe if someone's feeling generous, maybe it could even be a 3 marker. But yeah, probably more like a 2 marker. Basically, it's distance to top of climb. So they'll give you a brakes. Well, there's 2 types of questions actually. There's one where they give you brakes release weight, and there's another one where they actually start you at an intermediate point, which is a little bit more mucking around, and that in fact could be a 3 marker, I suspect, because there's more calculations to do. But anyway, we'll do the easy version first, and then maybe after we have a couple of coffees, we'll do the harder one. With a little bit more brain power required for that. Okay, so we've got a brakes release weight, and basically we're just going to calculate what's the distance, how far. The question is how far are we going to travel, what's this distance here over the ground before we get to flight level 330. Okay, so remembering the rule for climb, the most important rule for climb is, and that's the standard rule, and it works out to be basically correct mathematically, is that the correct average wind is about 2/3 the height. So the average wind, you spend about half your time below that point and about half your time above it. So it turns out to be mathematically a fairly accurate result, is that if you use the wind at about 2/3 the height, you get about the right result. And after all, you've only got 3 winds given anyway, so it sort of makes sense that you'd be using this one here. Okay, so and remembering the chart, which you're going to look up, which is on page 29. Yeah. Why are we looking at that chart? Well, first of all, we look at here and go 2/3 the height is going to be, well, 2/3 of 33,000 is 22,000. What's nearest to 22,000 is about this one. So we're looking at the ISA deviation for this one, not this one, although they happen to be the same, but I suspect in an exam they wouldn't be. So these happen to be both, this happens to be ISA plus 10. Remembering the rule, the CASA rule is you round to the nearest 5. So if it's ISA plus 12, you'd use ISA plus 10. If it's ISA plus 8, you would use ISA plus 10. If it's ISA plus 7, you'd round that to 5, and then you'd have to average between the 2 pages of the book, which would be a bit, because then you'd be averaging 4 numbers, which would be a bit more work. But anyway, we've picked ISA plus 10, makes it a bit easier. We do have to average between the columns though, because it's 78 tonnes is not given in your chart. So if you look at your chart on page 219, you'll see that it gives you 76 tonnes and 80 tonnes. So we're going to have to average those 2 columns at flight level 330 to get the value. Okay, so let's do that. So according to my chart here, 76 tonnes. Actually, you guys can probably give me that number. 76 tonnes. What's the distance to the top?
25.
25 miles or 25 minutes?
Distance is 168.
168 nautical miles, and then obviously 80. We're going to go to 80, and then we're going to have to average the 2.
So that's 196.
196 miles. So we're going to average those 2 numbers there. So 182. Let me just double check that to make sure we get that right. So 76, yep, so 76 at flight level 330, yeah, so that's 168, and 80 is 196. So we're on page 29, on page 2-9, yeah. Okay, so it's saying if actually the question would be finished if we were in nil wind, if there was no wind, that would be the answer. We'd be saying, yeah, this is 182 miles, but of course the table can only ever give you air distance, not ground distance, so we're going to have to calculate the effect of the wind. So we're going to have to calculate how long we're exposed to that wind to get the effect of the wind. Obviously, the longer you're exposed to it, the more effect it's going to be. Maybe you can give me those numbers, Clint. So again, we're going to have to look up the 2 times. It's going to be something like 30 minutes or something like that.
Yeah, it's 5 minutes apart, so 25 minutes at 76 tonnes.
Yeah.
30 at 80.
We'll keep the decimal, so 27.5 minutes. I always tend to keep the decimal with the minutes because it can make a difference, especially when you're doing gear down calculations and fuel dumping and those ones. You'll find it's actually best to keep the decimal, because especially with fuel dumps, because you're dumping about a tonne per minute, so half a minute can mean half a tonne, so you could be half a tonne out if you round the decimal the wrong way. Okay, so you are going to be exposed to that wind. Remember, we're using the average wind here, which is 235. You're going to be exposed to that wind for 27.5 minutes according to the table. So we better calculate that wind component. So track is, and home viewers will be using their cosine table. I'll be cheating and using my scientific calculator. So these are, by the way, notice I've given that as a true. So remember, by definition, RSWTs are true. So we get away with it there. Obviously, if this was given as magnetic, you would have to either change them both to magnetic or both to true. It doesn't matter. That's up to you, whichever you prefer. Obviously, it works in both. As long as they're all in the one unit, it all works. So according to me, that's plus 47 knots. So in other words, it's pretty close to being, in fact, it's only 20 degrees off being a direct tailwind. So the ETAS therefore is going to be nil, because you can see that if it's a direct tailwind, the ETAS is always going to be, you don't need to work it out really, you just know it's going to be 0, because there's very little crosswind. It's only going to be about 20 knots of crosswind, which is not enough to affect the ETAS at all. Okay, so question is, how much does that affect you? Well, basically, simple. 27.5 minutes at 47 nautical miles per hour. That's how much it's going to affect you. And of course, it's tailwind, so it's going to carry you a little. So if you look at your aircraft climbing, so here's your aircraft climbing, you're going to be carried just that little bit further forward in that time of 27. So it's going to take us, by the way, the wind doesn't affect the time to top a climb. Why is that? Why doesn't the wind affect the top of climb? Time. It affects the distance, but not the time.
Because he's staying in that body of air, like it's not.
Yeah, I mean, it's a vertical distance. This is the vertical distance, 33,000 feet. So the vertical height is not affected by the wind, which is horizontal vector. So the two vectors are perpendicular to each other. So basic physics there will tell you that those two can't affect each other. So the 27.5 can't be affected because they're at right angles. They can't affect each other. So the rate of climb is a vertical component. The wind is a horizontal component. They don't affect each other. They're completely separate entities. So yeah, some nice little physics there, and I know it does. So actually the rate of climb is also not affected by wind as well. It doesn't help you get up, it doesn't help you come down. It doesn't affect the rate, it affects the distance over the ground, but it doesn't actually affect the rate in, if you put it in feet per minute, that number is not affected by any amount of wind. Okay, so how much are we affected? Well, simple. Distance equals speed by time, basically. We've got 47 knots exposed to that for, we better put it in hours, so we better divide by 60. So basically half an hour at 47 knots, so it's going to be about, 25 miles, something like that.
Yeah, 22.
So basically you're allowed to round that one off, 22 miles. In other words, that's a tailwind, so plus, so the ground distance is going to be simply 182 plus 22. So that's your answer, 204 nautical miles.